Okay, so R-OTE has completed our noise analysis. We come up with two distribution outputs. One is a histogram of the duration distribution of error bars, and the other is the distribution of error bars or the errors in the specific D or R event. So distribution in duration, which is the difference between D and R, is different than the actual D and R event itself. Now what we report is the D or the R itself. So I'm going to click the duration off. It's going to be saved, and we can refer to it later if a researcher asks us for that information. I'll focus on the distribution that we get for the error bars for the D or the R, and they're equivalent, and so we're only looking at the D here, but the R is exactly equivalent. If the Monte Carlo solution came up with a result that was exactly the same as the event that we had for the maximum likelihood, it would have come up with a report that the event was on the red line. So the histogram shows that most of the events that come out in our simulations fall on the red line. Now some of them deviate from the red line, or they deviate from our event that we detected, and those can be plus or minus. And we notice that at the 0.6827 confidence level, we see that those error bars are fairly tight to the event that we found. But if we jump to the 0.95 confidence levels, those error bars are much wider. And if we go to the 0.9973 confidence level, meaning 99.73% of all of the events that came up in our Monte Carlo simulations fall within these error bars, we see that the error bars are much wider, in this case more than 10 times the original 0.6827 error bars. So I'll just show that if we wanted to superimpose the Gaussian distribution on the best fit, I can show that by replotting these. I'm going to just look at the D that we did. So this gray plot is the distribution of our actual error bar analysis. The blue line is the distribution if we had a Gaussian distribution. This goes to show that error bars for occultations are not parametric. They are not Gaussian, and they don't fit any normal student T chi-square power or other types of distributions. We've tried them all. The only way to come up with the error bars is by running a number of simulations and actually plotting the distribution. So the ones that we're going to report are the 0.95 distributions, these two bars here. Now this particular graphic is saved in our folder, so I'll click that out. And that one is saved. I'll click that out. And here is our report. The report is the error bars for 0.6827 in readings, 0.95 in readings, 0.9973 in readings, and also in seconds, because we can convert the readings using the time delta to seconds of time. We have the 0.6827 in seconds, 0.95 in seconds, and 0.9973. And these are the values that will actually report out when we put our report back to Brad Timerson. But for now, what we want to do is we want to save this output. This output is the only screen production. These are not produced in any separate report. So we're going to save these, and we're going to do this by printing this out. To a PDF file. If you print it out and it comes up with your printer here, you just change it from your printer to a PDF file. Now this works very well in Google Chrome. It may not work quite this way in Internet Explorer, which is one of the reasons why I use Google Chrome. And so we're going to save this. Right now it's in landscape. It's a little nicer if it's in portrait. And then I just press save. And I come up with the folder that I'm currently working in. I have to give it a name. So I'm going to go to the error bar report that I produced the histogram file for. And I'm going to say it's a summary report. And it's in PDF format. Press enter. And now my report is saved. And I can produce that report for Brad Timerson later from these error bars. So we're just about done. Now that we have our error bar report, I want to go back and locate to our locate square wave page. We still have our original report that we want to save, and the best way to do that is I want to go to Write Reports, and I want to write the associated plot files for this report. And it shows both the zoomed in light curve that we solved for and the original light curve with a square wave superimposed. Those are going to be saved in our folder. That's nice. And click those out. And then I want to go back to locate square wave page. And the last thing that I want to do is I want to save all of this. So all of this is important documentation to save. And I'm going to save it in a PDF file. And the PDF file, I want to be sure that I don't lose that time information. So I have to go from portrait mode back to landscape mode. Now I have all of my time information saved. And I see I've got a little hiccup here in that. So I want to change my margins to, let's go minimum. And now I've got all of my report saved. Got a little bit of a page break issue, but at least all the data is here. And I'm going to save that to a PDF file. And I want to name it, so I'm going to name it, because it's a square wave solution, I'm going to name it for the R-OTE square wave summary.report. much done. We captured our report. We captured our error bar. And the last thing that we could do is capture this screen, so we capture what it was that we actually searched on. We might want to remember that we did a mag drop limit here. If somebody else wants to try to reproduce our results, the only way they can do that is to use the same parameters that we did in our analysis. So I'm going to do a Control P on this window, which is going to save these values for us. Again, I'm going to save this as a PDF, and I'm going to call this the square wave summary, but I'm going to call this Part 1 summary. And I want to change this other summary. I could have done this when I first did it, which I didn't, to Part 2. So now I've got two summaries. I've got the data summary, which I'm going to call Part 2, and I've got the other summary, which is the window summary. I'm going to call Part 1. And now we're done. So the final step will be, and we will perfect this for our process. The final step would be to open up our original report file that we got from Brad Timerson. Go to our data page. We would look, let's see here, we'll move this around a little bit. So we can look here and we see that the times right here, this is our report page. This is the observer report. When I reported this originally, I reported out a D at 11:08:07.73. And sure enough, R-OTE produces a time of 11:08:07.73. So that time is still good. My reappearance time is 11:08:19.709. And sure enough, R-OTE comes up with 11:08:19.709. Now, if these results had been different, we could modify these numbers when we submit the report back to Brad. Okay. Now, so those numbers are good. The other thing that we're going to look at is, I want to go back to our error bars, and if we compare the error bars that I reported back in 2015, scoochy this over here, you'll see that I reported error bars that are a little different than what I got with this analysis, and I reported the 0.6827 error bars as opposed to the 0.95. So we're going to report the 0.95 error bars. I'll copy that, paste that here. Well, if I can't paste it there, I can paste it up here. Press enter. Go here. And so these would be the new error bars that we provide at 0.95 confidence level. Then we would save this file, we would submit it back to Brad, and our analysis would be complete. That ends this video presentation.